Man, you gave me a hard one here. Engineering with pumps is unique in the fact that water chemistry is different throughout the United States. So you have to design a product that can operate from really hard water conditions, really unique water conditions, really deep to really shallow. It's diverse. It's not one specific chassis or one specific part. You've got to design for multiple levels, multiple opportunities of what you're going to be pumping.
The most unique thing is just the way water behaves. A lot of people think they understand it, but it's far less intuitive than you'd think. I know fluid dynamics was one of my hardest courses in college, and now I know why. The smallest different details can so much change how the water behaves. It's a great learning curve, and it's a very interesting thing to play with.
I've worked with water in the past, but I hadn't worked with fluid dynamics the way they have to with vane technology and impellers and everything.
My background is electrical engineering degree. I'm doing the electric motors. As you might know, water and electricity don't tend to mix well together. So the aspect, especially for our submersible well pumps in the design and manufacturing of those motors, is to isolate and keep that water away from the electrical components is one of the unique challenges in the water well pump industry.
With working with VFDs in relations to water pumps, some challenges that may arise are coming up with happy set points that can work for all of America as a whole, or all of our customers as a whole, because no two wells are the same. So you need to have a drive that is very flexible and can achieve pumping groundwater efficiently for everybody.
Water, it's a lot of fluid mechanics. Have to deal with how water flows, how you can push it up, how you can pull it down. Depends on how much of it, you're moving a lot of it, and it can be hard to work with.
From my experience working in the water well industry, I found that it's kind of a hybrid pace. It's not as fast-paced as the automotive industry, but it's not as slow-paced as like a government job. It's not as fast-paced because you're not looking to design for aesthetics like you would in the automotive industry, where you need to come out with a new model every year. Once you develop a good working model, it can last many years, but you still need brevity for improvements and customer quality.
By nature, there's two things that we typically work with, I guess, is everything is powered by a motor. So we have a lot of electrical engineers who got to know the nuances of not just motors work, but how does electricity in an item affect what happens? Because sometimes it has consequences, because you're talking about a lot of things that involve magnetics and sine waves and other things like that. The other aspect is mechanical engineering, really, which we're now using impellers to move water. And there's a lot of nuances to what does geometry do to an impeller? How does water flow through a pump? Again, there's a lot of nuances for how all these things work together. Having good, strong understandings of electrical systems and mechanical systems are very important for pump engineering in general. Those are kind of the areas. Then I guess a third one you can attack onto there is controls, because every one of these motors got to have a way to turn on. The controls for these things are getting more sophisticated as we go on. So understanding your application and what you want that pump to do and what that pump may face, if you understand that, you can develop a controller that can take inputs and understand what the environment's like and adjust your pump to the situations that it may encounter.